I'm going to talk about parallel and transverse lines that go through them. So they're called parallel lines and transversals. First thing, let's understand what we're looking at when we look at a just a line. It could be, if it's cut apart, and I just use this as an example down here, with the line that comes off of it like this. This forms two angles, okay? And they're called supplementary. If I look at this one, I'm just going to make some numbers up here. If this is a 60-degree angle, this one would have to be, making a different size line, 120 degrees. And the reason why is simple. This going from here to here is 180 degrees, okay? We got to keep this concept in mind when we're looking at this. Even though we're moving the line about, we're not just having it nice and flat. We're not using a flat line for this. It's a line that's going to be all crooked. It's the same concept, okay? So we look at this thing. If, for example, I'm just going to erase something. If let's say we don't know what this is. And let's say this one, for example, is 110 degrees. And I called this X. It's probably one of the first problems you start to do is you can say, well, how can I make it 180 degrees? It's just 180 minus 110 equals 70 degrees. To make it 180 degrees, this has to be a 70-degree angle going from here to here, okay? This concept is going to ring through everything you're going to see coming up, right? So let's look. If you have parallel lines, both of them work under the same principle, right? Principle is going from here to here is 180, right? 180. There's no difference, okay? If you had a perpendicular line running through this, and I'll throw one up there for funsies, right? If you go like this, and this is completely perpendicular. I don't know if I can make that look perpendicular. Remember, lines have to have pointy ends, right? Then you'd have a line segment otherwise. You would put little boxes here, like this, and here, and like here, and like here. If this was perfectly perpendicular, right? Then what can we say? This is 90 degrees, this is 90 degrees, this is 90 degrees, this is 90 degrees. So this is 360 degrees all the way around here. And the same would be true here, okay? None of that's going to change. But if we put the line off and not perpendicular, we skew that line, okay, you end up with a situation like this. Now, what makes this fascinating, and let's say if we went with our other model, let's say if this was 120 degrees here, this would be 60 degrees that could be used to make up the rest of that line. Remember, it has to be linear. It's a line. The same would be true right here because these are parallel lines. This would be identical, 120, and this also would be 60 going from here to here, okay? What's interesting is if you remember the definition of a vertical line, this would be equal here, and this one's going to be equal here. So if we look at this, these two are 120, and these two are 60, okay? What's the term we use for this angle and this angle? Now, we can't say they're the same angle. They're in different locations, but they have the same measurement, in this case, 60 degrees. We call them congruent. They're congruent angles, which means they have the same measurement at 60 degrees. They're congruent at 60 degrees. For these guys, it'd be 120. These guys would be congruent as well at 120 degrees, right? If we were to look at this, and I'm going to clean the slate here, look at the way this looks, we can determine several things. These guys that I'm shading in, these are vertical angles, so they'll be equal, right? These are vertical angles, so they will be equal, right? We look at these guys, the bigger ones, the obtuse ones. Remember, these are cute because they're small, less than 90. These are obtuse because they're bigger. These guys would all be equal, right? So when you start looking at this, you see a very similar pattern. It's just a matter of its, I guess, geolocation on this transversal. Parallel lines with the transversal is to know what number you would use, okay? So there's actually a key for this. I'll show you what this looks like. It kind of looks like this, right? If you have the letter A, okay, and let's say we're looking at this and we say A is 60. I keep using the same numbers over and over. C would equal 180 minus 60, right? So this would be 120. Once you get one of these angles, you can find everybody else. This is 120. This would be 60. This would be 60. This is 60. This is 120. And this is 120. I'm going to clean this up because I wrote all over it. But the easiest way to think about this is that they have to match based on the way this thing's designed. So A, D, and E, and H. So A, D, the light blue colored ones, E and H would all match. They're all congruent acute because they're less than 90 degrees. Then the other ones, C, B, G, and F, C, B, G, and F are bigger than 90 degrees. They're obtuse, right? And they would all be equal. To find one from the other depends on if it's obtuse or actually, it doesn't matter. I guess it's obtuse or acute. You just know you're going to be subtracting it from 180 to find the opposite one. Okay. I'm going to run through a couple problems and you're going to see how this works. Okay. I'm going to try to keep this short, but here's my first set of problems. All right. This one says it's 76. What is this guy? Well, I know this one matches this one, which means this one matches this one. So X has to equal 76 degrees. Sometimes you could shade them in if you get confused. This has got to equal, this has got to equal, right? This one looks a little more confusing. 138 matches this guy, which also matches this guy and this guy. He doesn't match. So you have to go 180 minus 138, okay? So that's going to be a whole 42 degrees, okay? So you'll get a set of problems doing these, and it's just a matter of finding out which guy you're looking at, okay? Now, I'm going to do a more complicated problem, and that is one that has letters and numbers and whatever it could be in here, right? So this goes back to the ideal of doing equations. Just make sure you got the right guy you're looking at. So if we look at this, these two are equal, right? That means these two are equal. I mean, if you want to make it a little more easier to see, remember, this guy has to match that guy, which means this guy matches this guy if these are parallel lines with the transversal. All right, so I'm going to clear this off for a second so I can see what numbers have to match. This says that 53 degrees has to be equivalent to X minus 11. And this goes back to one of the earlier chapters. Add 11 to this side, add 11 to this side. All right, this would be 64 equals X. So the answer is 64, right? Now, suppose you had a problem, and I'm going to change this. Well, actually, let me do this in next, and then I'll change it around a little bit so you can get comprehension here, right? This guy, look at here. This guy matches this guy, so this guy matches this guy. He's not matched, okay? So how do you find this one? Once again, you take 180, you minus 110. I'm going to get 70. That's I have to find this angle. He's got to match that angle, right? So now, I'm going to clear this up a little bit so I can see what I'm doing. I know that this has to match 70 degrees over here. So I put 70 equals X plus 12. I'm going to subtract 12 minus 12. Right, so 58 equals X. Right, so this one would be 58. Now I'm going to make a little more complex one. Right, let's do one where, let's say this says instead of X minus 11. Okay, I'm going to put this over here, and I'm going to say I'm going to make it 8X minus 11. Now I have a two-step equation here. That's the only differences, right? So I just rewrite it. Remember, these two guys have got to match based on their position. This one matches this one. Therefore, this one matches this one. So it's 53 equals 8X minus 11 plus 11 plus 11. 64 equals 8X. Divide by 8. Divide by 8. 8 equals X. So this is stuff that you've done in 6th grade, and obviously do it 7th grade, 8th grade. It's this stepped equations are being used in here too. So X is equal to 8. Okay. So that's kind of the concept. Hopefully this helps a lot in your understanding.